Today we'll start the chapter 5, Numerical Differentiations. Okay, and differentiation is actually the rate of change, and numerical differentiation. Okay, we are going to learn the first derivative using 2-point backward, 2-point forward, 3-point centra, 5-point formula. Then the second derivative using 3-point centra, 3-point formula. Okay, and as you know, actually the differentiation can represent the slope, okay, which is y equal to dy dx, or rate of change, which is, okay, let's say if x is a displacement, then you have the velocity is actually your dx dt, and the a is actually the acceleration, is actually the rate of change of your velocity. Okay, and why we need the numerical differentiation is actually when, okay, we have a set of discrete value is given instead of function. Okay, first of all, okay, we look at the 2-point formula for the first derivative. Okay, you can have 2-point forward difference or 2-point backward difference. Okay, if you look at the figure A here, if you are standing at the point X, okay, and the ahead point with the interval h, so this point is actually x plus h. So the value here, the y value here is actually fx. Okay, this point is actually fx plus h. Okay, as you know, actually your y prime is actually dy dx. So the difference of y divided by the difference of x. So the difference of y will be your fx plus h minus fx. The difference of your x is actually h. That's why, okay, using this figure A here, you can get the 2-point forward formula as a fx plus h minus fx divided by h, okay, plus order h. Okay, later on I will explain what is the order h here. And then using the figure B here, you can obtain the 2-point backward, okay, formula for first derivative. So similarly, okay, when you're standing at x, okay, the y value for here is fx, and the y value, okay, this is the fx minus h. Backward because, okay, at the back of your current point of x. So this is x minus h. So similarly, okay, the first derivative represent actually dy dx represent the slope. So dy will be your fx minus fx minus h dx here is actually increment h. That's why you obtain the 2-point backward formula as a fx minus h divided by h plus order h. The order h here is actually represent the truncation error. Okay, how we obtain the order h? Mean for 2-point forward formula, beside using figure A here, where you derive using the geometric and the concept of the slope, we can also obtain the first derivative for 2-point forward or backward using Taylor series expansion. So this is a Taylor series expansion for fx plus h, which is equal to fx plus h f prime x plus f double prime x divided 2 factorial. So multiply h squared plus, if the third derivative divided by the 3 factorial, and then h cube up to, if you have n derivative, then divided by n factorial multiply h power n. If you are interested on the first derivative, then we want this term f prime x, and then f prime x will be equal to fx plus h, minus fx, and then this term also, and then we take up to here, actually up to this term. So the second derivative over 2 factorial h squared you bring to left hand side, so you have minus h squared over 2 factorial, and it's actually you have something like here fx plus h minus fx minus f double prime x divide 2 factorial h squared equal to h f prime x. So all this term we truncate already, and then for f prime x you obtain here by dividing by h. That's why f prime x you obtain fx plus h minus fx divided by h. So h squared divided by h. So this is what represented by order h, mean the truncation error of order h. So up to now, do you have any question? So similarly, you can use a Taylor series expansion to obtain the 2-point backward. Mean you expand the fx minus h. Then we obtain this formula here. If you got no question, we move to the 3-point formula for first derivative. So this is a 3-point formula for first derivative is actually equal to fx plus h minus fx minus h divided by 2h plus order h squared. Similarly, you can derive it using Taylor series expansion or using this geometrics. So x center for you have a head, the point x plus h, backward x minus h. So the y value, this will be fx minus h. This point is fx plus h. Using the concept of slope, the dy is exactly fx plus h minus fx minus h, your dx. the difference of x. Here you have h total is 2h. So far, any question? Okay, if no, okay, we have the 3-point forwards given by this formula. So for the 3-point centra, 3-point forward and backward, okay, the truncation error is exactly order h squared. Okay, to get the truncation error, we can derive the 3-point forward and backward different formula using Taylor series expansions. Then this is the 5-point formula for first derivative, which is the order h power 4. 5-point, okay? So actually this fx plus 2h negative and then plus 8 times fx plus h. Even though 5-point, like 3-point centra, we not involve the point fx. The point fx similar to 3-point centra, not involve this point. So you when you're standing at the center x, so this is 1-point okay, backward, 2-point backward, 1-point forward, 1-point, 2-point forward. Okay, you compare to why we call the name 3-point forward. Okay, current point fx, 1-point forward, 2-point forward, 3-point backward. Okay, you are standing at the x. So okay, going to the back, 1-point, 2-point. So this is 3-point backward. Okay, and for second derivative, okay, we have a this is 3-point centra is equal to fx plus h minus 2fx plus fx minus h divided h squared plus order h squared. And then this is a 5-point formula for second derivative. So 1, 2, 3, 4, 5. So 5-point formula for second derivative. Okay, we involve also the fx point.
Doktor,
Yes.
dia memang ada negatif untuk 5 point ni yang depan sekali. Negatif F kurungan S plus 2H.
Should be correct.
Oh, okay. Thank you.
Let me check. Yeah, correct. Negative fx plus h. This is negative, positive, positive, negative. Correct.
Okay, thank you.
So basically, the numerical differentiation, you need to find the first derivative, second derivative, okay, using all these appropriate formula. Okay, example 1. Given the following set of discrete data, you have this data. Okay, find the approximate value, okay, of the f prime 0.4 and f double prime 0.4 using all the appropriate different formulas. Okay, so you f prime 0.4 mean the x standing here. Okay, and you see the increment for each data is exactly your h equal to 0.1. Okay, so this point will be your fx. Okay, this is the fx plus h, fx plus 2h. This is fx minus h. This is the fx minus 2h. So you see, okay, you can involve, okay, you have all the point actually, fx plus h, fx plus 2h, fx minus h, fx minus 2h. Hence, okay, in this example, you can calculate the first derivative using all the formula and also the second derivative using 3-point centra and 5-point centra. Okay. Then you just plug in into the corresponding formula. Okay, for 2-point forward difference, mean you are standing here and you know, okay, your first derivative is actually dy dx. So forward. So taking the point ahead. So will be your fx plus h minus fx divided by h. Okay, fx plus h you have 1.284. fx is 1.402. h is 0.1. Then you calculate it. So we get, okay, the answer here, negative 1.180. So, okay, in the test or final, okay, if you want to skip, write down this formula, this part, okay, then at least you write down here. Mean at least this part and this part. So is it okay for 2-point forward? And then similarly for 2-point backward. Okay, this is a fx. So this is fx minus h. So quickly, 2-point backward mean you have this one, 1.402 minus 1.531 divided by 0.1. This is a 2-point backward different formula. Then plug in fx 1.402. 1.402 fx minus h 1.531. Your h is actually, you take 0.3 minus 0.2, which is 0.1. 0.4 minus 0.3, 0.1. Mean 0.5 minus 0.4, the increment is 0.1, and so on. So this is the h. Calculate it, you will get negative 1.290. Okay, any questions?
Doctor,
Yes.
for backward and upward, is it we can choose either one, backward or upward for this question?
Forward, not upward. The question, find using or. Using or. So
Oh, okay.
you can use 2-point forward, backward. And then also, okay, fx minus 2h. Also 3-point backward, 3-point forward, 5-point formula. So you must calculate using all appropriate different formula. Mean if you just calculate, let's say 2 point forward, okay, the rest of the method, then you lose the marks.
So means that three method is it need to solve by this question for this question.
I think 6 formula.
Sorry. So yes.
2 point forward, backward, 3 point centra, 3 point forward, 3 point backward, 5 point formula. Six method. So if you just calculate one method, okay, we lose the mark for another 5 methods. So is it clear? Because the question all the appropriate different formula.
Clear, doctor. Sorry. Thank you.
Welcome.
Doctor,
Yes.
Doctor, for 2 point forward formula, do we have to plus order H?
No need. That one mean the truncation error.
Oh, okay. Okay.
So to calculate, we just okay, 3 point centra is a fx plus h. This is approximately equal minus fx minus h divided 2h. So the plus order h squared is actually if the truncation error, the order is higher, normally will be more accurate. So mean compare 3 point and 2 point, 3 point is more accurate. If compare 3 point and 5 point, 5 point is more accurate because the truncation error is higher order. So this is a 3 point centra. So this is a fx. This is a fx plus h. This is a fx minus h. So 3 point centra. You're standing here. You take the point ahead, divide the point behind, divided. Cause here you have 0.1. Okay, here 0.1. So total 0.1 plus 0.1 is 2 times 0.1, which is 0.2. In here, quickly you can calculate as 1.284 minus 1.531 divided by 0.2. Because 2 times 0.1, which is 0.2. So is it okay?
Clear, doctor.
Okay, later on this is the 3 point. Okay, I'm not sure. 3 point forward. And this is a 3 point forward formula. Okay, the formula will be given, so don't worry. Meaning you just plug in according to the formula. So this is the fx. So fx plus h, fx plus 2h. Cons negative of fx plus 2h. So it will be negative 1.177, then plus 4 times fx plus h. So plus 4 times 1.284. So minus 3 times fx minus 3 times 1.402. Okay, divided by 2h. Okay, h is actually 0.1. 2 times 0.1, you have 0.2. So calculate using your scientific calculator in one step. If you're using MS, make sure your numerator you have bracket before you divide by 0.2. Okay, if you use ES onward, key in using the natural display in the fraction form. Then you'll get this answer. So 3 point forward, is it okay? Okay, if no, we proceed to the 3-point backward. So for 3-point backward, this is fx. So at the back, going back, looking back, this is a fx minus h. This is a fx minus 2h. fx minus 2h. Then the 3-point backward. Okay, this is a 3-point backward for first derivative. Okay, is approximate equal to 3 times fx. So 3 times 1.402. 3 times 1.402 minus 4 times fx minus h, which is k minus 4 times 1.531 plus 1 time fx minus 2h, so plus 1 time 1.671 divided by 2h. 2 times 0.1, you have 0.2. Calculate in one step, you should get this answer. So far, is it okay?
Okay,
Okay, then we move to the 5-point formula for first derivative. So this is the 5-point difference for first derivative. So this is a fx, this is a fx plus h, fx plus 2h, this is a fx minus h, this is a fx minus 2h. Then you plug in k accordingly to the formula. So negative fx plus 2h. So negative 1.177 plus 8 times fx plus h is this. 8 times 1.284 minus 8 times fx minus h, which is 1.531. Okay, plus fx minus 2h, which is 1.671. Okay, divided by 12h. 12 times 0.1, so you get 1.2. So calculate in one step, you get negative 1.235. So you see, for this example, you can calculate the first derivative using all 6 formula. Then you have to calculate using all these 6 formula. If you miss up one, then you will lose the mark for the method that you left out. Okay, and then we look at the second derivative using 3-point and the 5-point formula. Okay, 3-point central difference is given by fx plus h minus 2fx plus fx minus h divided by h squared. Okay, and then you look, this is a fx. So this is a fx plus h. This is a fx minus h. So fx plus h, which is 1.284 minus 2 times the fx, which is 1.402 plus 1 time fx minus h, which is 1.531. Okay, divided by h squared. H is 0.1, so 0.1 squared. So calculate in one step, you'll get this answer. So this is a 3-point centra, and then for the 5-point difference for the second derivative. Okay, this is the formula. Again, this is a fx. This is a fx plus h, fx plus 2h. This is a fx minus h. This is a fx minus 2h. Then negative fx plus 2h. So will be negative 1.177. Yeah. Negative 1.177 plus 16 times fx plus h. So here 16 times 1.284 minus 30 fx. So minus 30 times 1.402. Okay, and then plus 16 times fx minus h. So you have a 16 times 1.531, and then minus fx minus 2h. So minus 1.671. So divided by 12 squared. Okay, let me show you. You calculate one step. I need to find my calculator one. Okay, this one you calculate one step. We have negative 1.177 plus 16 times 1.284 minus 30 times 1.402 plus 16 times 1.531 minus 1.671. Okay, divided 12 times 0.1 squared. So before you press, okay, double check whether you key in correctly. So 1.1. So in your answering during test or final, you may if you want to write down the formula, okay, and make this step, okay, this one if you want to skip, okay, this one if you don't write down formula, so at least you have this step and this step. So far, okay, any question? We are finish example 1. Okay, example 2. Okay, given this data here. Yes. Yes, who want to ask? Okay, anyone want to ask questions just now?
Doktor, jawapan dia memang semua sama setiap solution.
No. Not same. Just now the second derivative is the same, but normally the answer not same.
Okey doktor.
because this one we don't have the exact solution, so we cannot compare. Okay, cannot compare and show to see actually the 5-point formula is the most accurate. In the second one should be 3-point formula. Okay, example 2, you have this, okay, the data of time and velocity, means velocity at different time. Okay, the velocity in the meter per second, the time here is second. So you have the time 1.7, 1.8, 2.2, 2.4. Okay, find the acceleration. A is actually equal to dv dt of the car at t equal to 2 seconds using appropriate different formula. Okay, here the answer given is 7.25. Okay, you want to find the A. The A is actually, okay, this is t. So this is the function of t. V is actually the function of t, and A is actually dv dt. So you want to find the first derivative of your f prime t, and then you want to find, okay, dv dt at t equal to 2. So yes, okay, 2, but the data f2 is not given. F2 you don't have. So from 2, okay, if 2, okay, to 2.2, the h is actually 0.2. Mean the h you can have 2.2 minus 2, okay, or 2 minus 1.8. So you get this is 0.2, 0.2. So you see from 2.2, you add up 0.2, this is 2.4. Okay, but from 1.8, 1.8, if the h, mean here, if the h is 0.2, you should have 1.6, but you don't have f 1.6. Okay, so in this case, okay, what we call the f2 is actually your ft because the function is t. So this point, this is actually ft plus h. Okay, 1.8 is actually ft minus h. Okay, 2.4 is actually ft plus 2h. Because from 2 to 2.2, you have 1h. 2.2 to 2.4 is actually add up 2h. And then from 2, okay, going back, okay, you have this is 1.8 is actually t minus h. And then, okay, if you minus h one more, it is 1.6. Mean the ft minus h, minus 2h. Sorry. We don't have the, okay, the ft minus h. We don't have ft. What we have is the point ft plus h, ft plus 2h, ft minus h. Hence, in this case, can you use let's say 2-point forward to calculate your, okay, a here, which is dv dt. You won't. Yuwen, are you around? So it's okay. Who is sitting in front of your the laptop there? Nobody. Siti Soleha. Siti Soleha.
Yes, doctor.
Can you use for example 2 here? Can you use 2 point forward to calculate the dividity? Yes or no?
Yes.
Okay, you look back the 2 point forward formula. When you all didn't understand the formula. This is a 2 point forward formula. Okay, you need fx plus h. X in this example is actually the t. Okay, you have this one you have. Do you have ft? Do you have ft?
No.
No, that's why you cannot use 2 point forward. Okay, 2 point backward. Okay, the formula is fx minus fx minus h divided by h. So similarly, can you calculate using 2 point backward? Do you have ft?
No.
So also cannot. Okay, and 3 point central.
Can.
Yes, means A is actually the f prime t equal to f t. So the x, the formula x, you change it to t. So it will be ft plus h minus ft minus h divided 2h. ft plus h is actually 14. ft minus h is 11.1. Okay, h is actually 0.2. Okay, then calculate it. Where is it? Okay, you calculate this one. Do you get 7.25?
Yes.
Yeah, okay. Okay, how about the 3 point forward, 3 point backward?
No, because we don't know.
Okay, we cannot, okay? Look back. Okay, this is second derivative. Let's see. Three point forward, we also need the fx. In the example 2 is ft, but we don't have the ft. So we cannot calculate using 3 point forward different formula. And then for 3 point backward, okay, 3 point backward, also we need the ft. But the ft value is not a variable. Okay, looking back, okay, how about the 5 point formula for first derivative? Okay. the 5-point forward, we don't have this one, ft minus 2h. We have the ft plus h, ft plus 2h, ft minus h, but we don't have the point t minus 2h. Because the x, the t is actually just now is 2. You have, okay, hold on, this one difficult. Look. Okay, look. This is a 5-point different formula. Yeah. Okay. Okay, for the 5-point different formula, you have the, okay, t plus h. Okay, this is t plus h, t plus 2h, t minus h. You don't have the t minus 2h. So that's why, okay, for example 2, you can only calculate the acceleration, exactly the dvdt, which is equal to f prime t using 3-point centra, because not involve the ft value. 3-point forward backward involve the ft, so cannot be used. Okay, 2-point forward backward also involve ft, which is not a variable. 5-point formula cannot be used because you don't have ft minus 2h. So the only variable formula is 3-point centra.
Doctor,
Yes.
why we don't have the t minus 2h?
Okay, if you choose the h is 0.2, because the question 1 at t is 2, 2. So 2, okay, to 2.2, increment is 0.2, right? Correct.
Yes.
Okay, 2, okay, 2 decrease to 1.8 with the, mean the decrement is 0.2, right? Mean 2 minus 0.2. You get 1.8. Mean here t2, you're standing at 2 here. So if you add 0.2, you get 2.2. 2.2, you add 0.2, you get 2.4. So the 0.2 here is what we call h. This is the h increment. 1.8, okay, increase to 2 by increment 0.2. Okay, 1.7 to 1.8 increment is how much? 1.7 to 1.8. What's the increment?
0.1.
So this is the h. This h is 0.1. So this data, because if kt2, this is a ft, 1.8 is t minus h. If you want to minus 2h, mean 1.8 minus 0.2. Okay, minus 0.2, you should get 1.6. But f 1.6 is not a variable. You have is 1.7, not 1.6. So that's why you cannot calculate using that 5-point formula, because you need the ft minus 2h. And you cannot calculate using 2-point forward backward, 3-point forward backward, because you don't have the data ft. When t equal to 2, this is a f2, which is a ft, is not a variable. So 2-point forward backward, 3-point forward backward cannot be used. 5-point cannot be used because you don't have f 1.6. Because For 1.8, you should minus 0.2. You should have 1.6. When t 1.6, what is the velocity? But in this case, you don't have. You have what you have. This is 1.7. If 1.7 to 1.8, the h is 0.1, not 0.2. So that's why 5-point formula cannot be used. Okay, is it okay?
Okay, doctor.
Okay, later on the third example. Okay, given the fx equal to cos x, and then now approximate f prime 0.6 and f double prime 0.6 using 3-point central formula with h equal to 0.1 and h equal to 0.01, and then state which h give a better approximation. So now, the question just focus on 3-point central formula for first and second derivative. And then we would like to make conclusion, whether a smaller h or the bigger h will give a better approximation. And since this one is the exact function, you can differentiate to get the exact solution, and h and hence we can find the absolute error. The previous example 1 and 2, we don't have the function. That's why if we want to find differentiation, you have to use the numerical differentiation. But this example is actually purposely want to demonstrate whether a small h or bigger h will give a better approximation. That's why we just fix one method only. And from fx equal to cos x, you can differentiate directly to get the first derivative, which is negative sin x, and the second derivative is you differentiate negative sin x, you get negative cos x. And then your f prime 0.6, because you want to approximate f prime 0.6. So you plug in, you will get negative sin 0.6, which is equal to negative 0.5646. And then the second derivative for f double prime 0.6 into negative cos x here. So I have a negative cos 0.6, which is negative 0.8253. So this is actually the exact solution. Exact, or what we call analytical solution. So of course, means if you have a function, you can differentiate directly. Then you no need the numerical differentiation. But we purposely want to show whether the small h or bigger h will give better approximation. Then later on, we using 3-point central formula for first and second derivative. And then we'll compare with this exact solution in terms of absolute error. So the smaller error will give better approximation. So the 3-point central for the first derivative, you have the formula f prime x is actually approximate equal to fx plus h minus fx minus h divided by 2h. So you have two different h. So the left case side is h equal to 0.1. Then using 3-point centra, different for first derivative. So the f prime 0.6 will be, okay, your fx is cos x. So plug in into the cos function. So cos, okay, x that you're going to estimate is 0.6. So put in. Your fx is cos x. So cos, the x is 0.6. So h is 1. Oh, sorry, this is 0.1. The solution and the question not there. Then you change the questions to tally with the solution. So okay, for h equal to 0.1, so cos 0.6 plus 0.1 minus cos 0.6 minus 0.1. So divide by 2 times 0.1. So you also can calculate in one step. Then you compare this one to get absolute error. So for the h is 0.01, you just replace here. Okay, I will put it here. Cos. Okay, h. Okay, we don't have the h. Just put it a. This is minus. So it's a cos x plus the h I represent using a. And then minus fx minus h will be cos x minus a divide by 2a. You calculate, okay, x, estimate the first derivative, second derivative at 0.6. So x is 0.6. The h, okay, the first case is 0.1. Let me see whether the solution. So let me check, okay, whether this one. Yeah, that's now in degree. So you get negative 0.5637. So mean the question you change the h to 0.1 and 0.01. Okay, calculate again. Still the same h, so you press down key, change the h now to 0.01. So you get negative 0.5646. So how to get this absolute error? Here. First derivative, the exact value is negative 0.5646. So mean your absolute error is exactly negative 0. This is second derivative. (5.646) magnitude minus negative 0.5637. Mean you can take the see the absolute ABS. Okay, negative 0.5646 minus negative 0.5637. So this is 0.0009. Okay, and then for h equal to 0.01, exact and the approximate same. That's why the error is 0. Because you have your error is exactly negative 0.5646 minus negative 0.5646. Hence, so which h give a better approximation, which is h equal to 0.01 give a better approximation. Okay, means to get a accurate answer, we will we take the smaller h. So any question here? Maybe for example 3 here. Any question?
No,
No
doctor.
question.
Okay, if no, okay, the second derivative will be similar. Mean this is a second derivative using 3-point centra, and the fx is cos x. So you have a cos. Okay, this one change. This is 0.1, 0.01. So f double prime 0.6 will be using the 3-point centra. If you have the cos, this is x, 0.6 plus 0.1 minus 2 times cos. X is 0.6 plus cos. Okay, 0.6 minus 0.1 divide h squared. And then when the h is 0.01, then you just change accordingly. Okay, then to calculate it, okay, you can modify it, point h squared. So it's fx plus h minus 2, okay, cos. Not sure whether it multiplies, so better I put multiply. 2 times fx and then plus cos x minus h. Okay, then you calculate x still 0.6. Okay, let's say h is 0.01 first. So you get negative 0.8253. Then you calculate again, x still 0.6, h now is 0.1. So you get negative 0.8246. Okay, and the exact solution for the second derivative is negative 0.8253. Is the error negative 0.8253 minus negative 0.8246. Two five three minus negative 0.8246. Why did you put the absolute none? Okay, if you get negative, you take the magnitude. So which is 0.007. Okay, for h equal to 0.01. Okay, the error is exact. You have negative 0.8253 minus approximate, which is obtained from numerical differentiation, which is negative 0.8253. So you get 0. So again, Okay, for second derivative, okay, smaller h, which is h equal to 0.01, give better approximation. Better approximation. Okay, so okay, any question before we proceed to okay, I think the example 4.
Clear, doctor.
Okay, example 4 here. Estimate the first derivative at x equal to 0.5. 0.5. Yeah. Using h equal to 0.2h, using all appropriate formulas. Okay, so x 0.5 and then increment 0.25. So this is x. So this point, okay, 0.5 add up 0.25. 0.25. 0.5 you add 0.25 is 0.75. Mean this is x plus h. So this is the fx plus h. So from 0.75 add up 0.25 is 1. So here, this is x plus 2h. So this is the fx plus 2h. Okay, and then if 0.5 minus 0.25, yeah? So you get 0.25. So this is the x minus h. This is the fx minus 2h. So you okay? You're standing x equal to 0.5. If using h is 0.25, 0.5 plus 0.25, which is 0.75. So this is okay, fx plus h. Okay, from 0.75 add up 0.25, you get 1. So this point is x plus 2h. In this point, not using. This one not using. This one not using. Then from 0.5 minus 0.25, you have fx minus h. So this is h, sorry. This is fx minus h. So this example, you have the point fx, fx plus h, fx plus 2h, fx minus h. Okay, you don't have fx minus 2h. Hence, you cannot calculate using 3-point backward, because 3-point backward, okay, from fx, this is 1 point, fx minus 2h, 2 point. You need fx minus 2h, but you don't have fx minus 2h, so cannot use 3-point backward. We just want first derivative. So you cannot use 3-point backward. So similarly, because you don't have the fx minus 2h, you cannot use 5-point formula. Because 5-point formula, you need fx, fx plus h, fx plus 2h, so 3 point already. So fx minus h, 4 point. You need one more, which is fx minus 2h. Because you don't have fx minus 2h, hence you cannot use 3-point backward, 5-point different formula. Okay, and then you can use fx plus h. So you can use 2-point forward. Fx and fx minus h, you can use 2-point backward. If you use fx plus h and the fx minus h, this is 3-point central. If you use fx plus h, fx plus 2h, which is 3-point forward. So you from egg formula, you only cannot use 3-point backward and 5-point formula. So you still need to calculate using that 6 appropriate formula. So let's look at the 2-point forward. So fx plus h, which is the 0.6363 minus the fx, which is 0.9250 divided by h. H is 0.25. Hence, you get the answer negative 1.1548. So is it okay? If example 1, you can calculate using all egg formula. Example 2, you can calculate using 3-point central only. And then example 4, for first derivative here, you can calculate using 6 formula. So this is 2-point forward. Later on, 2-point backward. You can use 2-point backward because you have this is the fx, this is the fx minus 2h. So which is the fx 0.9250 minus fx minus 2h, which is 1.1035 divided by h, which is 0.25. Then you get negative 0.7140. So any questions here?
Doctor, the H should be 0.25, right?
Yeah. So here h 0.25. Yeah, about the previous slide. H 0.25. If you already printed, please make the corresponding make the changes. Got some typo. And if the answer is wrong, please let me know. So this is 2-point backward, then 3-point central, 0.25. 3-point central, you have this is fx. Here is fx plus h. This is the fx minus h. Then plug in fx plus h is 0.6363. Fx minus h is 1.1035 divided 2 times 0.25, you get 0.5. Then you get negative 0.9344. Is it correct? If no, the 3-point, I think forward. This is correct. 0.25. 3-point forward. This is fx. This is fx plus h. F fx plus 2h. Okay. So you plug in accordingly to the formula. So negative fx plus 2h. So negative 0.2 plus 4 times fx plus h. So 4 times 0.6363. Okay, minus 3 times fx, which is minus 3 times 0.9250. 2 times h, 2 times 0.25, you get 0.5. Then you should get negative 0.8596. I think just now I made mistake. Okay, for first derivative, you have six formula. Six formula because 2 point forward, backward, 3 point central, and then 3 point forward, 3 point backward, 5 point formula. Because we don't have the fx minus 2h. We don't have the fx minus 2h. Okay, that's why cannot use 3 point backward. Backward, you need this point, one more. Mean from point 25 minus point 25, mean we need the point x is 0. Mean you need f0. But we don't have f0. That's why cannot use 3 point backward. 5 point cannot because also left out. Okay, fx minus 2h. We have only 1, 2, 3, 4. Not enough. Okay, value. So mean you can calculate using only 4 formula, 2.2, and then 3 point central, 3 point forward. Total 8 formula because add up 2 more formula for second derivative. This is also 0.25. 3 point backward cannot use because we don't have this point. This is the fx. This is the fx minus h. We don't have this one. f0 we don't have. Okay, 5 point formula. We also don't have the fx minus h. Because this is the fx. You have the fx minus h, but we don't have fx minus 2h, which is the f0. Okay, fx plus h is actually f0.75. Okay, fx plus 2h, which is f1. f1. This one we don't have this one, fx minus 2h. That's why cannot use the 5 point different formula. So we have completed the numerical differentiation. Do you have any questions